In this video, we're going to focus on calculating elasticities. And the formula is the same, no matter whether we're talking about price elasticity of demand or income elasticity of demand or any other kind of elasticity that is different from the standard 4. It's always the same formula done in the same way. So just to briefly review that idea, elasticity is always measuring how a change in one thing, let's call it A, causes B, something else, to change. And we always are interested in percentage changes in A and percentage changes in B. And A is going to be the cause, B is going to be the effect. And the formula is always the percent change in the effect on the top divided by the percentage change in the cause on the bottom. So the larger this ratio, the larger the ratio between the effect on the top and the cause on the bottom, the more elastic something's going to be, because we're talking about a bigger effect on the top. So we call this kind of thing, no matter what kind of elasticity, the A elasticity of B. The first word is the cause, the second word is the effect. So the most common one is price elasticity of demand that we study in economics. If we're doing this formula and the top of the formula is larger than the bottom, we call it elastic. If the top is smaller than the bottom, we call it inelastic. And if the two are equal, we call it unit or unitary elastic, because the elasticity is going to be 1 or minus 1, and unitary is just a fancy word for 1. The price elasticity of demand is the one we focus on a little bit more, but if you really understand price elasticity of demand and how to calculate it, it's the same kind of thing for the other elasticities. Let's get started with price elasticity of demand. Since price is the first word, that's going to be the cause, and we're going to want to put the percentage change in the price on the bottom of our formula, and the percentage change in the amount people are buying on the top. That's the effect we're trying to measure. So we're measuring how much quantity demanded responds to a price change. And since it's always negative, or possibly zero, but never positive, we sometimes will ignore the minus sign, just to remind you, okay? No other elasticity are we ever going to allow you to drop a minus sign. But sometimes you'll see an elasticity for price elasticity of demand, they'll just write down the positive number. Okay, so let's dive in. And if you're going to learn this, make sure you have your calculator out and on in front of you and you do these calculations along with me, okay? The simplest way you'll ever see to calculate an elasticity is if somebody gives you two percentage changes, right? All you need are the percentage change in quantity demanded and the percentage change in the price. If somebody hands those to you, it's extremely easy. You just divide one number by the other. Takes you just a second. So let's just run through 3 quick examples here. Suppose we saw the price go up by 5%, so that'd be a plus 5%. Quantity goes down that people are buying by 10%, so that'd be a minus 10%. What would the price elasticity of demand be? Calculate it. So of course, as we see in our formula up here, the effect we're looking at is the quantity, so that would be minus 10% on the top, divided by a plus 5% on the bottom, and that would give us an elasticity of minus 2, price elasticity of demand of minus 2. And we see that that's elastic because the absolute value is bigger than 1. The top is bigger than the bottom in absolute value, the magnitude, right? So we would interpret this minus 2 as telling us for each 1% change in the price we see on the bottom, we're going to see twice as large an effect in the amount people are buying. And that's why we call it elastic in this case. The response is bigger than the cause that we're looking at. Now what about the second one here? What if we saw price go down by 12% and the quantity people are buying went up by 3.4%? Take a second and calculate that. All right, so we're going to have here a response where people are buying 3.4% more. The cause is price went down, so that's minus 12% on the bottom. and you divide 3.4 divided by minus 12, and we get an elasticity of minus 0.28. And here we see, because the effect, the 3.4%, is a much smaller change than the 12% cause on the bottom, we're going to call this inelastic. And this interpretation of this minus 0.28 would be, for each 1% change in the price, we see a 0.28% change in the quantity people are buying. So if the price is going up 1%, people will buy 0.28% less. And if the price is going down 1%, people would buy 0.28% more. What about number 3 here? We see the price go up by 8.1%. We see the quantity go down by 8.1% people are buying. Calculate the elasticity. Well, since the top and the bottom here are both 8.1%, and since this is a decrease, this is going to be a minus 8.1% on the top, divided by a increase in price, so that's a positive 8.1%. On the bottom, we get an elasticity of minus 1. That's unit or unitary elastic, and that means that whatever the price change is, we're going to see the same magnitude of quantity change. But because of the law of demand, when price goes up, quantity goes down, those changes are always going to be moving in opposite directions. If price goes up, quantity goes down. Okay? So this is the simple case here to calculate price elasticity of demand. The 3 other common elasticities that you always see in a standard economics book, and let's just write out what the formulas for those 3 would be. Again, let's go back to our rule. If you memorize this basic rule here, that the first word in an elasticity is a percent change on the bottom of a fraction, you're done. That's all you really need to know. You don't need to memorize a lot of different formulas. It's really just one. So the first word here is price. So price elasticity of supply, the formula is going to be the percent change in the first word on the bottom, price, and the percent change in the quantity being supplied on the top. The income elasticity of demand is going to be the first word on the bottom, percent change in the income on the bottom, and the percent change in the quantity people are buying on the top. I'm not going to call this quantity demanded because income actually shifts a demand curve, right? But what we're talking about is we see a situation where nothing else is changing except income. So ceteris paribus, income is changing, and we look to see what happens to the quantity people are buying as a result of that income change when nothing else is changing in the market. And then the cross-price elasticity of demand. Remember, what cross-price means is we're looking at the price of a different good. So for the cross-price elasticity of demand, we have to specify 2 different products that we're observing at the same time, and the price of one changes, and we want to know how the quantity people buy of the other thing changes. So the formula, the first word here is the cross price. That means the price of the other good. So we could call this the percent change in the price of, say, good 2, the other good, and we want to know what is the percent change in the quantity people are buying of good 1. And it's always important to think carefully about which good is which when you're calculating this. So, for example, we might want to know what's the relationship between the price of gasoline and the quantity of heavy trucks that use a lot of gasoline that are purchased, because those 2 things are complements. They go together, right? So if the price of gasoline goes up, we might see people buying less large cars that are gas guzzlers or large trucks that are gas guzzlers. So once you know those formulas, anytime you see the percentage changes, all you have to do is put the right percentage change on the top or then the bottom, do some division on your calculator, and you're done. Except, of course, we're never done. We have to interpret what it means, right? So we want to say, is it elastic or inelastic? And what does that elasticity actually mean, just like we did with these three over here. Now, just a couple of quick things to mention, and then we'll talk about how to do this with raw data. But a couple of things we want to mention here before we go about these other elasticities. Price elasticity of supply is usually positive because the law of supply says this. The law of supply says that ceteris paribus, when the price goes up, the quantity supplied will increase. And indeed, this is usually the case, probably 98% of the time, 99% of the time. However, in our previous video, we discussed a case where we see with brain surgeons and heart surgeons and some other medical specialists that when the price they as individual people get paid goes up, sometimes they decide to work less and actually enjoy the lots of money that they're earning. They don't have to work as hard and they can still have a high income. But usually price elasticity of supply is going to be positive. Income elasticity of demand can be positive or negative. And if income elasticity of demand is positive, what that means is if people's incomes go up, and that's a positive number, right? And we see also that people buy more, so the percent change in quantity is also a positive number. If those two are both positive, or if they're both negative, those negative signs will cancel. That means that we're talking about a normal good. A normal good is just one when your income goes up, you buy more, and when your income goes down, you buy less. However, there are inferior goods. So if we get a negative sign for an income elasticity of demand, we know that we're talking about an inferior good. For example, we might have a case where your income is going up, but we see people buy less of the product. So income goes up 10%, people buy 5% less. That would be something like ramen noodles or something like store brand crackers or store brand pizzas. And then cross-price elasticity of demand can also be positive or negative. And here we're looking to see whether the two goods are complements or substitutes. And so if in a case where the price of one good goes up, and we see that causes you to buy less of another good, that tells us that those two things are complements. And here's the logic. Consider something like hot dogs and hot dog buns. If the price of hot dogs is good too, and that price goes up, you're going to buy less hot dogs. And if you buy less hot dogs, that will lead you to also buy less hot dog buns on the top here. So the price of hot dogs goes up, you buy less hot dog buns, you're going to get a negative over a positive, which gives you a negative. However, a positive sign must mean that we have substitutes. So, in this example, if the price of one thing goes up, and that causes you to buy more of another thing, that means the other thing must be a substitute. So, for example, if the price of one brand of bottled water increases, that might lead you to buy more of a different brand of bottled water, and so that makes those two things substitutes. Or we could go in the opposite direction, right? We could have a negative, and those two signs will cancel, giving us a positive for substitutes. So if the price of one brand of bottled water goes down, that will mean you'll buy less of the other brand, because now it's relatively more expensive compared to the first brand than before. Now here's kind of the hardest thing in this section is, what if somebody doesn't hand you these percentages on a silver platter? You need to know how to calculate these percentages. So if you're given raw data, how do you do that? Well, some people will calculate percentage changes the standard normal way that you were taught in 6th or 7th grade. However, most of the time, what you'll see economists doing is calculating percentage changes using something we call the midpoint formula. So most of the time in an economics class, we'll ask you, use the midpoint formula. What is the midpoint formula? Let's look at it with an example here. I have the formula written here, but it's a little easier to see what it means with an example. Let me give you a brief rundown. Elasticity, as always, is a percentage change over a percentage change, and all we're talking about here is a way to calculate a percentage change. It's actually a little easier than the normal way that you were taught. So what we want to do to calculate a percentage change, let's just focus on the top here. Suppose we wanted to calculate the percentage change in quantity. What we do is we take what was the change in quantity? How much did the amount people are buying change? So you take the original number, you take the later number. What's the change between the two? We're talking about subtraction, right? How much did it change? That goes on the top. On the bottom, we take the average of the two numbers. Add them up, divide by 2. You get the average. And then we multiply that by 100 to get the percentage change in quantity. And then we do the same thing for the other percentage change on the bottom. In this case, it's going to be price, since we're looking at price elasticity of demand. We take the change in price divided by the average price times 100. All right, so let's look at an example here. So we just want to calculate two percentage changes and then do the ratio just like we did before. Here we have two prices. The price was $10. The price is now $15. Let's calculate the percentage change in price first. So percent change in price equals. So the formula says, what is the change in price between $10 and $15? Did it go up or did it go down? And by how much? Well, here, 10 to 15, it went up by 5. So that change in price, remember the little triangle there is the letter delta, which is a shorthand for change in. So the change in price is going to be up $5, so plus 5, divided by. Now, on the bottom, we want to know what's the average price. What's the average of 10 and 15? This is why we call this the midpoint formula, because the average of two numbers is going to be halfway in between the two, if you were to picture them on a number line. Now, if you're ever unsure, take the time to just add 10 plus 15 on your calculator, and you'll get 25. Divide it by 2 to get the average, and you'll get $12.50. See how that number, $12.50, is halfway in between the two numbers, the midpoint? All right, so $12.50 is the average of the two prices. And then we multiply that times 100 to make it into a percent. Okay, so we have 5 divided by 1250 times 100. Do that on your calculator. So what we get is 40%. So this is a 40% change in the price. All right, we'll need that in a second. But before we do that, we have to get the percent change in quantity. So we're going to do the same kind of procedure here. Percent change in quantity equals, well, what happened to the quantity? The quantity went from 100 before to 80 after. On the top, we have the change in the quantity. How much did the quantity go down? It went down by 20, right? So 100 down to 80 is minus 20. It went down 20, so we're going to call that a minus 20. And then on the bottom, we want to know what's the average quantity between 100 and 80. What's the number in between those? If you're ever unsure, add them up. Get 180 divided by 2, and you get 90. All right, so 90 on the bottom times 100 to make it a percentage. Do that. Tell me what you get. So we get negative, right? Since one of these numbers is negative, the other is positive, we get minus 22.22222%. And now to calculate the price elasticity of demand, we have to put the percent change in price on the bottom, since that's the first word in the name. So our final calculation is, what's the percent change in price on the bottom? 40%. And put the minus 22.2% on the top. And that will give us our final answer for price elasticity of demand. What do you get? We get minus 0.56. So as always, once we calculate something like this, that's not when we're done. We're done after we interpret it and we make sure we know what this means. Price elasticity of demand, minus 0.56. The absolute value's less than 1 because the top is smaller than the bottom, so it's inelastic. Not extremely responsive to price, right? The amount people are buying is not extremely responsive to price. And what else could we say here? Standard interpretation is, if we have a simpler example, we can always put 1% on the bottom and the minus 0.56 on the top. So a very simple interpretation would be, say, 1% increase in price, there will be a 0.56% decrease in the amount people buy. Or we could multiply the top and the bottom by 10. 10%, multiply the top by 10. Minus 5.6% change in quantity people will be buying. So that's how you use the midpoint formula. Now let's do one more example to make sure that we have it. Here's some data that I just pulled off the internet a little while ago about cigarette sales in Ontario in Canada. Here's a graph over time where we see from 1980 through about 2014 how many cigarettes in billions were sold in Ontario, the province, I'm assuming here, not just the city, so billions of cigarettes per year. I wanted to just pick 2 years here to look at. So I wanted to pick a time when the price of cigarettes was changing a lot in Ontario so we could calculate an elasticity. Look at the price change, look at the quantity change, and calculate an elasticity. And I saw this point here where it looks like between around the year 2000 and say 2006, they were increasing the tax a lot per cigarette in Ontario. It looks like the tax per cigarette, if we look over here on the right, say in 2000, might have been around 2 cents. And by the time we get to about 2006 here, it looks like the tax per cigarette might be somewhere around 12 or 13 cents, right? So let's assume that that's 13 cents. What that tells us about the price is if we're buying a pack of 20 cigarettes, which is the normal thing to do, right? And before in 2000, the tax was 2 cents per cigarette. I looked it up and it seems like the pre-tax price of a pack of cigarettes back then was somewhere around $3. So that's without the tax added. If we add in 2 cents times 20 cigarettes, that gives us about 40 cents in tax way back in the year 2000. If we add 13 cents per cigarette, 13 times 20 gives us $2.60 in tax for that pack of cigarettes. So we have our two prices. Before this huge tax increase, a pack of cigarettes was probably about $3.40, including the tax. After, probably somewhere around $5.60. This isn't perfect data, but it's what I was able to Google in a few minutes. Now, if we take these prices and we look at the quantities in this graph of those 2 years, again, this is approximate looking at a graph, and we go from the year 2000 right here to about 2006 right here. It looks like the quantity of cigarettes sold went from around 17 or 18 billion down to somewhere around maybe 12 billion over here, okay? So let's call it 11. All right, so we have some quantities here. Let's calculate the percentage change in quantity and the percentage change in price, and let's see what the elasticity is for smoking in Canada during this time. All right, so using our midpoint formula, our percent change in the quantity, we want the change in the quantity divided by the average quantity, multiply that times 100. Okay, well, what was the change in quantity between 2000 and 2006? Down 9 billion. I'm just going to call that minus 9. We could put all those zeros for billion on there, but if we don't put it on the top or the bottom, it would just cancel anyway. So minus 9. What's the average of 20 and 11? Well, 20 plus 11 is 31. 31 divided by 2 will give us 15 and a half. And then we multiply that times 100. You do that and see what you get. Make sure you can get the right answer. So I'm getting that that's about a 58.1%. Negative 51.8% change in quantity. Wow, that's a pretty big percent change in quantity. Okay, but we're talking about a pretty sizable increase in the price of cigarettes as well here. So let's see. Let's go down to our price change here, and let's calculate the price change as a percentage. Okay, so percent change in the price is going to be the change in price divided by the average price times 100. Well, the price went from $3.40 to $5.60, so do some subtraction. What was the change in price? So we want to do the after minus the before. Looks like $2.20. And then we want to divide that by the average of those two prices to find the midpoint. And we get $4.50 times 100. All right, see what percentage change you get there. I get about a 48.9% if we round that off correctly. So 48.9%. Let's put these two numbers together and let's see what we end up with. We have our minus 51.8% change in quantity caused by a 48.9% change in price. Let's see what we get here. I'm getting an elasticity, price elasticity of demand for cigarettes in Ontario of minus 1.06 approximately. Now this is very interesting. This is elastic. Now remember, sometimes people would just omit the minus sign because this is a price elasticity of demand. No other elasticity would we do that, but I like to leave the minus signs to make it more clear. But here we're seeing that the price elasticity of demand for smoking in Ontario is elastic. Now this goes contrary to previous discussions we've had about elasticities. Let's look at our elasticities we were talking about before. The elasticities for smoking, 0.4 for adults in the short run, 0.75 in the long run. Here we're talking about a 6-year period. But that elasticity is a lot bigger than one might expect. Is there any way we could possibly explain that? How is it that people in Ontario might be more elastic than what these other numbers have found? Well, let's go back and look at our list of things that can affect the price elasticity of demand. What percentage of the budget does this good take up? Well, I don't see any specific reason why it would be different in Canada than in the United States, where most of these other elasticities come from. Second, are there good substitutes for this? Well, here's what I'm thinking, and I've read a lot of articles about this. In Canada, during the 2000s, a lot of the provinces, British Columbia, Ontario, a lot of areas in Canada were raising their cigarette taxes drastically. And people started looking for substitutes. And there are a few interesting articles on substitutes that you can find. One of the most common articles you'll see is about how after these high increases in taxes in Canada, people would drive to the United States, load up their car with cigarettes, and then bring them back into Canada. So it seems that because there are substitutes, cheaper substitutes to be found in the US, that perhaps that is why this elasticity is more responsive. People in Ontario are able to find a substitute by driving down across the border into the United States, find a cheaper substitute, and then bring them back home instead of paying the tax and actually buying their cigarettes in Canada. This is how you calculate elasticities. What we're going to do in the next video is we're going to graph a straight line demand line, and we're going to calculate the price elasticity of demand using the midpoint formula for each pair of points as we lower the price and increase the quantity to see what happens to elasticity as you move along a straight line demand curve. And we're also going to investigate what happens to the total revenue as the price and the quantity changes along a straight line demand. As always, if you have questions, please let me know. I'd be happy to try to point you in the right direction. Otherwise, this is Mark Berkey signing out. Good luck with all your studies, guys.